Hello everyone, this is Wei. I'm a software engineer at Facebook Infrastructure. With me today is Harish. He's a technical manager at AMD. Today, we're going to talk about OAMTool. OAMTool is a vendor-agnostic utility that manages the OAMs. First, I will discuss the problems we are facing in terms of managing different OAMs in the hyperscale data center. I will also talk about why we think OAMTool can solve these problems. I will then hand it over to Harish to talk about the proposed architecture of the tool and our Phase 1 features that we are going to implement. The goal of the Open Accelerator Infrastructure, or OAI, is to outline open, modular, and hierarchical infrastructure for the interoperable accelerators. The Open Accelerator Module, or OAM, defines a common form factor for the accelerators to reduce system design complexity and enable quicker time to market for new technologies. However, the common form factor is the first step to enable an interoperable environment. Managing the OAMs from the different vendors in the hyperscale data center is still a challenge, and we need to solve this problem. Now, let's take a look how the different OAMs are managed today in a hyperscale data center, even after we consolidate the different accelerator hardware to a common form factor. Here, let's assume we deploy 3 different types of OAMs in our data center. These OAM will be managed by a vendor-specific utility, a different flavor of the SMI. NVIDIA uses NVIDIA SMI, AMD uses ROX SMI, while Habana uses Habana SMI. On the other hand, the requirements for managing these OAMs in the data center are quite similar. In a nutshell, we want to achieve the following functionalities. We want to be able to configure the system using our tooling. We also want to monitor the health of these OAMs during their runtime. We also want to collect stats, error counters, error logs, and telemetry information from the modules. And finally, we want to be able to manage the firmwares on these modules. By now, I think it's easy to understand the challenges we are facing. Each OAM comes with its own vendor-specific tool, and each tool has its own command options and output formats. We will have to build vendor plugins for each tool to be able to manage the OAM in our DC. It is clear to see even the OAM enables interoperable environment, the management side of things certainly doesn't offer the same story. Furthermore, because DC tooling is customized based on vendor-specific tool, it is very difficult to switch to a different vendor. This creates an unwanted vendor lock-in situation. Considering the functionalities required to manage the OAMs are quite similar, and I think we can do a better job on this. We propose OAMTool. This is a vendor-agnostic or vendor-neutral utility for the OAM management. This is a common tool that manages the OAMs from multiple vendors. It is developed by the participating OAM users like Facebook and also vendors like AMD and Intel. The tool will be open source and carry MIT license. I want to mention that it is not uncommon to develop a vendor-agnostic tool to manage hardware modules from different vendors. Consider the EASE tool to manage the different NICs in the network world, or consider the NVMe CLIs to manage the SSDs in the flash world. With a common tool, the management of the OAMs in the DC will be greatly simplified. Our tooling team now only needs to develop one plugin to manage all the OAMs because all the functionalities will go through this common tool. Now I'm going to turn this over to Haresh to explain how can we realize such a tool, what is the software architecture, and what are the features of the phase 1 deliverables. Thank you.
Hello, my name is Harish. I'm part of the Machine Learning and Systems Engineering group in AMD. As Wei Zhang mentioned in the introduction, OAM end user doesn't want to use multiple tools. OAM hardware is vendor agnostic, so should be the tools. The OAM tool consortium have been actively working towards a vendor neutral solution. The architecture is quite simple. On the top, we have a vendor neutral API. I'll be going over the API in some detail in the coming slides. Each vendor, in turn, will provide a vendor-specific shared library that supports the API. An expectation here, at least for the first phase, is that within a compute node, all the OAM modules belong to the same vendor. The specification for phase 1 is almost finalized. It is drafted by the current members of the OAM tool consortium, namely AMD, Intel, and Facebook. The source code will be open sourced under the MIT license. As mentioned before, I will go over some of the salient features of the OAM tool that will be available in phase 1. OAM tool will allow you to query the list of OAM devices available in each node, irrespective of the vendor. The tool can also get detailed information about the OAM device. For example, what is its compute capability, how much memory it has, or what is the maximum power rating. The detailed list of information exposed is available in the specification document. The tool will also show you the detailed topology of how OAM modules are interconnected. It can show if two OAM modules are connected directly via a high-speed link. It can also show relative distance among all OAM modules and NUMA nodes. This information can be quite useful for a workload manager or a resource manager when scheduling jobs on that node. The simple health check feature allows you to check the status of an OAM module. This can be used before provisioning the nodes. The tool provides the ability to monitor various event counters. These are usually free-running counters exposed by the hardware. They are minimally invasive, so it can be used in a node that is actively executing jobs. This can provide valuable feedback to both system administrator and to the actual node users. An example of such counter will be a free-running coarse-grained OAM utilization counter. So if you record the value before and after a job is executed, it can provide a rough indication of how the OAM was utilized by that job. The same applies to other counters. Again, the detailed list of counters available are in the specification document. Firmware update. Ideally, nobody wants to update firmware. The vendors don't want to send firmware updates, and the customer don't want the hassle. However, the reality is a bit different. This tool allows the functionality to update certain kinds of firmware. The kinds of firmware that can be updated will be vendor dependent. However, the vendor dependency part will be handled by the vendor library, and the OAM tool user doesn't have to worry about it. The same OAM tool firmware update command will work across all OAM modules. The tool offers the capability to monitor different kinds of telemetry information. Apart from sensor information like voltage, current, and temperature, other information like memory usage, memory bandwidth, clock speed, etc. are also available. Last but not least, the tool also provides an option to configure OAM. Configuring modules will be limited to the privileged users. All monitoring features will be available with user privilege. For phase 1, we have one feature where OAM maximum power cap can be set. The plan is to finish all phase 1 features by second quarter of 2020 and all phase 2 features by end of 2020. We would like to welcome all OAM vendors and end users to join this effort. To get involved, please follow the links on this page. On behalf of all OAM tool members, I would like to say thank you.